Okay, I'm done. Shawn, on to you.
Okay, thank you, Amir. Thank you everyone for coming. We all really appreciate it. Welcome to our fireside chat on recommender systems, brought to you by Aggregate Intellect, or AISC for short. AISC is a community of machine learning practitioners and researchers who have gathered around topics in AI research, engineering, and products. And this is only one of many, many events that we host in an ongoing basis. There are events almost every day of the week, some along the lines of this and some focusing specifically on technical papers. Whatever your interest within the field, there's got to be some programming that you're going to enjoy. So if you want to know more about that, create a free account on our website if you haven't already. It's ai.science. You can also follow Aggregating Intellect on LinkedIn, and on YouTube we have a channel called Machine Learning Papers Explained. And if you sign up for that channel, then you can find out about stuff that we're doing in an ongoing way. So glad that everyone is here. Like I said, our topic is recommender systems, which is an interesting one in the machine learning world. It's a little bit different from almost everything else, actually. And that's why I'm really glad that we have three experts who are going to speak to us about recommender systems. Omar is a senior data scientist at RBC in the recommender systems team. He holds a master's degree in machine learning, specializing in recommender systems. He's also the stream owner and a researcher in the recommender systems stream here at AISC. Omar already has 2 patents with RBC and is working on multiple publications, specifically in the recommender system field. So welcome, Omar. I'll tell you a little bit about our next panelist, Serena McDonnell. She's a senior data scientist at Delphia, where she works on combining public opinion and social media data to create investment strategies. And I should probably talk to her about that. Previously, Serena worked at Mercatus Technologies, where she specialized in using machine learning to personalize the online grocery shopping experience and built the first recommender system at that company as well. Serena comes from a multidisciplinary background and has a master's of science in mathematics, focused on geophysical fluid dynamics and physical oceanography from Hong Kong University of Science and Technology, and bachelor's in math and biology from McGill. Thank you so much for coming, Serena. Our final panelist is Susan Shu Chang, who is a data scientist working in the fintech industry. I grabbed this bio and updated it, Susan, since you changed jobs. She trains and deploys machine learning models at scale, including a recommender system for millions of live customers. She also has expertise in reinforcement learning. Susan is also a game developer, a well-received public speaker, and someone who loves to volunteer and give back to the community, which she's doing right now along with everyone else. So welcome, everybody. All right, let's just dive right in. I'm going to start with a question that was suggested to me by Serena, and I think it's a pretty good one because when we think of recommender systems, we might think of Netflix or Amazon, but there's really like so many different variants and hybrids of it. So the question comes up, what even is this? So that's my question. I'm going to go in reverse alphabetical order by first name, starting with Susan. What is a recommender system to you? What does that mean?
Right. So I guess you have mentioned stuff like the commonly known like Netflix or YouTube or Spotify, where based on your behavior and what the algorithm detects that you like, it recommends things. But to me, on a more high level, why would a business even bother to do this? Like the first thing, it helps the user to find content, because on all of those platforms, there's a lot of content. So it actually saves the user's time, and then it saves the business time too, because like, let's say if YouTube had to send you a manual email every time your favorite YouTuber uploaded something new, right? Like that is a waste of time basically on the extreme case. But then for the business, it kind of creates a more engaged customer base as well, because you will keep returning to their platform. Yeah, so like this is how I think of recommender systems. And yeah, it sounds like more fluid than I would, because I've talked about this at my previous role a lot. I had to pitch a lot of people why we're doing this at all. So that was my pitch.
I like it. Thank you, Susan. Serena.
Yeah, I think Susan, a lot of what I'm going to say is what you said and also what Omar will probably say, but I would just say a recommender system, it makes content and information retrieval easier for the user. So it's probably best described by example. So yeah, Amazon, Shopify, or not Shopify, Spotify. I always mix up those two. So for example, when you're shopping on Amazon, you can see products that are suggested for you based on things that you've either looked at or you've purchased yourself. There's also the people like you bought X or they bought Y. That's another type of recommender system and would be implemented in a slightly different way potentially. So yeah, those features make it easier for people when they want to buy things online. And at my previous role at Mercatus or Mercatus, however you want to say it, I worked on personalization. So I would also say that anytime you talk about personalizing the experience for a user, I would say that's a recommender system. And I would even call something like Google. I would say Google at this point, it is a sort of recommender system. I was pretty horrified when I learned that, let's say my searches on Google are different from Omar's searches, and that could be based off of maybe my location or what I've searched before, any demographic info they have about me versus Omar. So yeah, that would be a recommender system too, because the results of the search engine, they're personalized. So yeah, just at a high level, it would be anything that makes it easier for people to retrieve content or anything that has this flair of personalization for the user.
Yeah, that's a great point about Google. I've just recently discovered the Google News Aggregator app on my phone, and it unnerved me, the series of articles, like no one is interested in all of these things except for me. So it was super accurate. I also think that I appreciated about your comment, Serena, just talking about how this is beneficial to the user. So maybe I'm a cynic. There's a part of me that just feels like it's beneficial to the company, right? Because you're putting things out there that you obviously want people to consume, right? Omar, what's your take?
I second Susan and Fina. It's the way I always talk about a recommender system is it's an extreme multi-label classification system, right? So you have thousands or hundreds or whatever of items, and you try to make sure that the best item goes to the most convenient user. So in my opinion, it's a very high complexity optimization problem. That's how usually I look at recommender system, right? So it's one thing that is a bit different than all the other machine learning fields is with NLP, most of the times you're dealing with LSTM, BERT, transformers, whatever it is. Computer vision, you're dealing with convolution neural networks, with deep learning neural networks. But then with the recommender system, you can mix and match all of those together. The goal is just to optimize the choice for the user. So that's essentially what recommender system is. You can work with it in banking, you can in retail, in entertainment, in logistics, whatever it is, there is an optimization technique that you can use.
Right, that's great.
I want to jump in. I really like your point about how flexible recommender systems are in terms of how you can implement them. So again, at Mercatus, so the first recommender system, not a machine learning one, but I guess you could consider it a recommender system. It was just a SQL query that just ranked products by how popular they were. And that is considered a very good recommender system baseline, but you can do that in an Excel sheet. And sure, you can do a neural network in an Excel sheet too, but it's not nearly as simple. So recommender systems can be very simple, and a lot of times a popularity model works great.
Right. Now I know all of you have major backgrounds in recommenders, and in multiple cases, the first recommender system at your company was built by you. So one thing I'm wondering about, and I'll ask you, Serena, is from an educational perspective, is there anything specific about this piece of ML where people need to focus their energies if they want to get involved, things they need to know and understand?
Yeah, I think that's a great question. So for me, at my last job, that was my first job out of my master's. So I still had this very academic mindset. So I knew that I was going to have to learn about recommender systems, but I didn't know anything about them. So I essentially it was like a self-taught course in recommender systems. So I started with reading what I would say is probably the most foundational paper we can call it as modern recommender systems, which is the paper that won the Netflix prize. So it's by Bell and Koren. So that's Bell, Bell, and Koren is Koren. I think it came out in 2007. And that talks about this particular matrix factorization method that they use that, again, wins the Netflix prize. And for any of you who aren't familiar with the Netflix prize, might be getting this wrong, but it's a competition where you had to create some recommender system that, recommends movies better than their Netflix's baseline recommender system. And I see Omar nodding his head, so I think I got that right. So yeah, that's one foundational paper. Omar, did you want to jump in?
No, that's the first paper I had to read in my master's
Yeah.
as well.
Yeah, exactly. So there's that paper, super important one.
Mm.
And even just going to Google Scholar and looking at all the papers that cite that one, I think that's pretty beneficial. And then just in general, it's important to explore matrix factorization approaches that are outlined in the paper. So making sure that you have a good handle on linear algebra concepts such as singular value decomposition. And then in terms of when you move to actually implementing, I think Susan and I, we've talked about this. The first recommender system that we implemented was an off-the-shelf implementation in PySpark using a method called alternating least squares. So that's also really great, reading that documentation. Yeah. And then following along tutorials on Medium that talk about movie recommendation. That was all really helpful for me when I was first starting out.
Okay, that's super practical and super helpful. I'm like scribbling down notes here myself, so thanks. One of the things I wanted to ask you guys about in machine learning, often the question comes up of evaluation. How do you evaluate the success of your model? If it's a recommender system, how do you evaluate the success of your model? What would you say, Susan?
Right. So yeah, I guess as Serena mentioned, and I second a lot of the things that she talked about, like on what to get familiar with. Actually, okay, so I'm gonna keep this thought for later. But yeah, back to the how it was evaluated. So a lot of the things that I implemented, so you can train the model and you can you can train it however you want in a sense. But actually my performance was almost kind of measured by business metrics in the end, which is when it's in production and it's showing up on people's websites, if the click-through rate has actually gone up. And it actually had like doubled in, I guess, like engagement metrics that were decided by the business. So I guess for the training purposes, I just use like pretty basic like RMSE. But however, it wasn't like, oh, I'm just having fun training it on my like VM. It's like, oh yeah, it actually has to be doing something for the customers, and then they actually are tracking the engagement, which this Rexis was being evaluated on. Because if it didn't really do anything, why are they spending money on it? I could be pulled to do another project. They could just have taken it off the website, but it actually wasn't. So I think that was a pretty good thing. And actually we had two models, as well as a rules-based, kind of like what Serena mentioned, like that was more like random. It wasn't SQL, but it was like based on some patterns the business had found through past engagement, and they put that into a set of rules. So there was actually two ML models going on at the same time, and then that set, and then the ML models performed better than that set. But basically, yeah, the evaluation was actually in production as well as with experiments as well.
Right. So business metrics, but hopefully it was also fun.
Yeah, it was fun, and we could have only known if it was doing well after it was deployed. Yeah, it wasn't known when I was just like deploying it in, let's say, a staging environment or like training it. Yeah, there was no way of knowing.
There's no baseline. Yeah. Omar, how did you guys evaluate your recommender systems over at RBC?
So basically what Susan mentioned is very important, because evaluating the recommender system, in my opinion, is much harder than building one, for multiple reasons, right? So if you look at the biggest recommender systems right now, when you're talking about YouTube, Amazon, Netflix, Spotify, even Google searches, all of those, they have totally different optimization. They're looking for different things. One of them could be looking only for click-through rate. So as long as you keep on clicking on the website, you're doing what's expected. One of them is just consuming content. One of them could be just spending some time, the duration in a session. At RBC, it's a bit different, because after all, we're offering products. So what we consider a successful recommendation or not is if the client wanted the product that we recommended or not. But again, that could be very challenging because maybe I can recommend you the perfect product, but it's not the right time. So there's a lot of factors that play in and play a huge part in determining if a recommender system was good or not. So because of the timing issue, we just wanted to focus if basically the client didn't like the product that we recommended. If they rejected it, then that's a negative impression.
Right, makes sense. One of the questions I had, I think that perhaps people in the audience, I know in my case, I did a recommender system when I was in school. And so the level of experience I have with it is quite basic. It's not the same as a production environment with millions of live users. So I thought maybe I'll ask you, Susan, just about roles and process when it comes to productionizing something like this.
Yeah, I think it's fairly important to think about that because when I was doing the model training, one actual big issue I had was what kind of data could I use? Because actually what Serena mentioned is the type of model that we used was based on, well, I guess I don't want to speak for like her company, but I'm speaking for the role that I was in.
You can speak for my company, it's fine. I also
Okay.
don't work there anymore.
Okay, true. But yeah, like it's based on matrix factorization, which means that you have to kind of compress the features into almost like a single value or I guess like some sort of way to represent it. So the way I had to gather data was slightly difficult because it's not like, I guess the common movie lens already has, let's say, on each user and how much they like each movie. Like it's already there. It's already in a matrix form. But the data I had was more about, we had website tracking, like website behavior. So like who logged in at what time and what did they click on and how's the duration, stuff like that. Did they click through and did they like complete the purchase flow? Like that was quite messy, to be honest, and it's not perfectly compressed in matrix form. So a lot of the front work was doing that, finding what is useful. And in this sense, I would say, okay, this is more a model training, less on productionalization, but that's part of it in industry. Like you have to really figure out ways to extract that real life data into a way that makes sense to the algorithm. Otherwise, you modify the data, you modify the algorithm. So I did that. And there was actually an evaluation portion. This is going on a bit long, but I had to show the business that this probably works. So I actually had to do a quick, maybe it was like 2 to 3 weeks long, like a kind of like a proof of concept. Like I whipped up a real quick version of it. And then I was just like, oh yeah, based on, it was almost like back testing in a sense, like, oh, based on this in the past, like if the recommender had been deployed, then based on what the customer actually did, it did match. Like there's some flaws to that, which I won't go into right now. There's definitely flaws with that. But then basically I had to say, yes, it's worth doing. And then the business was like, yes, okay, let's do it. So train the model, made more iterations, but then the data has to find a way to connect to the website front end. So I'm not going to go into too much detail. Sometimes you might have a, let's say a machine learning engineer helping you do this, but what I did was I basically helped write daily recurring jobs, like data pulling jobs, as well as running the model and then the model outputs. And so like all these data flows I actually did. And then because yeah, I wasn't throwing the code to a data engineer or something like that, a machine learning engineer, sorry. And then it was automated with the help of another data engineer who took my outputs downstream to feed it to, dumped it into a database that was then read by the website. Yeah, so a lot of stuff was going on there.
Yeah, no, it sounds like it. And don't worry about going on too long. That's why we're here. So I appreciate the insights for sure.
I just want to jump in quickly, Shawn, if you don't mind. I just need to make one clarification. When I said you can speak for my company, old company, since I don't work there anymore, I mean, the models might have changed. So take everything with a grain of salt. And also, Susan, you mentioned movie lens. And in case anybody isn't aware of what movie lens is, it's a very foundational data set that a lot of people use as their first data set when they're building some sort of recommender system. So yeah, you can look that up online and play around with it if you want.
That's great. Thank you, Serena. Omar, I just wanted to ask from your perspective over at RBC if you have any thoughts on roles and process from a production perspective.
Production, like taking a recommender system into production is a bit challenging, to be honest, for multiple reasons. There's training the data itself. For most of the times, given the amount of the data you're going to use to compress it into a smaller format to be fed to the model, you need eventually GPUs. And having GPU in a production environment is challenging by itself for a lot of companies. But it's not only that process when you're trying to compress the data. So in my opinion, the hardest part is not the modeling just by itself, but given that you have a database, your company or firm, whatever, you have a database, and then taking that data from the database and transforming it to the way that you want, to the way that is being fed to the model is the most challenging part. Because most of the times recommendation, a user wouldn't stay on a website more than, like on average, I would say, let's say if it's Amazon, they said that the average user spends from 3 to 5 minutes. So training and doing the data transformation, then training, and then serving definitely takes more than 5 minutes, right? So deployment for a commander system is very, very, very tough thing right now. And I know a lot of work has been done in it, done in that part, but it's machine learning and engineering is very, like, I couldn't do what Susan did for multiple reasons. Number one is the amount of the data we have. But obviously, you're talking about terabytes of data, right? So having that stream of terabytes into seconds, that was almost impossible for me. So most of the times what I do is I make sure that it's dev ready, everything is in dev quite well. Image the data, dockerize it, and then image the model, dockerize it, and then just upload it in a way where the ML engineers can put it in a production in a proper way.
Right. Makes sense. So in short, production is a big adventure.
Mm.
I'll shift gears for a second here. I have a question that is about AISC and your involvement. And I want to go around, maybe starting with Serena, and ask you guys, tell the group how you came to be involved with AISC and what benefits you get out of it, because we want everyone else to know and join and participate.
Yeah, definitely. Okay, so I became involved with AISC, I think, as a member in, when was it, maybe November 2018, I want to say. So I guess 2 years ago. It's been a while. And I had been working for maybe 6 months or so in my first job back at Mercatus, building recommender systems. And I was really missing the sort of academic environment that I had during my master's and during school. And a friend of mine invited me to an AISC event, and it was called Special Interest Group in Deep Learning at the time. And I thought it was awesome because it was just a group of people who loved talking about academic research, and they would discuss it. And I thought this was exactly what I felt like I had been missing. And then I ended up joining in the capacity of a stream owner, which at the time I think was called just steering committee member. Anyways, so so now I'm involved in various capacities. So I was a stream owner before. I'm not doing that so much anymore. Now I'm working on building diversity and inclusion into the product at AISC, or at Aggregate Intellect. And for those of you who might not know, the product itself, you can think of it as sort of an educational platform. So you can start from some sort of research paper, let's say, and you can learn how to implement that particular algorithm as a product. So you don't only get to learn these technical skills about how to actually implement cutting edge research, but you learn how to make it into a product that people actually want and people actually need and people will actually use. So that's pretty cool. In terms of what I've gained out of it, so I had never encountered machine learning research or read a machine learning paper outside of what I did at work, but I'd never done it really until I joined AISC. And I feel like I really developed technical skills and a deep understanding of many machine learning models. And I don't think I would have been able to do that just on my own, just by nature of having other people to learn from and having other people that I felt comfortable or feel comfortable to ask questions from. I think it's been really great. So yeah, anybody who's interested in learning more machine learning and just wants to meet like-minded people, I would definitely say you should join. We're a very welcoming community. We love new people. We love people who have stuck around for a while. So yeah, you can. I was just saying you can sign up for an account on ai.science, which is our website, and you can. Once you sign up for an account, you'll get added to our Slack, and then you'll get emails that notify you about all the exciting stuff that we have going on.
Yeah, absolutely. Yeah, thanks, Serena. I can attest to the friendliness. It's a really wonderful group of people. Before I ask Omar his take on this, something I meant to mention earlier is this is a technical event, but it's a networking event too. So if anyone would like to share social profiles, feel free to do so in the chat of this Zoom meeting. You can put your LinkedIn, your Instagram, whatever relevant things, so we can all continue to get to know each other. Now, Omar, what's your take on AISC?
I joined AISC in the same exact time as Serena did, in November 2018. And at that time, I had been only a year at doing my master's. In my bachelor's, I had almost no any interaction with machine learning, really. So in a year, I'm being overwhelmed with the amount of information, amount of papers, and I'm like, okay, I need a bit of support. I need to go and get help. I met a couple of people, Amir, Afan, couple of people from AISC. They invited me over, so I started attending these events, and it was extremely helpful in multiple things, right? So number one is in the first, I don't know, 4 or 5 events that I attended, I had no idea what was being said. I'm very new to the field. They're very, very smart and technical and deep people. It was very new to me, but one by one, step by step, I started learning a lot from them. And now I feel the amount of technical skills that I gained throughout just attending these talks, talking with them, asking them questions. It was very, very helpful for multiple things. And now we're actually forming a very small research group, and now we're trying to publish a couple of papers. I became a stream owner, I think, after a year and a half of attending. I became the Commander System stream owner, and I love being part of AISC. Like, there's so many smart people. I met Serena, Susan, Amir, everyone through AISC.
That's great. It sounds like the roles that the group is taking on are only continuing to expand. Susan.
Yeah, I definitely echo that. Actually, Serena probably knows when I joined, because I actually don't I don't know, like 2017,
I think it was February 2018. No, 2019.
Okay,
yeah.
So a couple months after. True. Yeah. So yeah, I don't know. 2017 and 2018 are like the same to me. But what I think I liked about it was I also came from like a master's background, and then I kind of missed getting together and talking more in depth about papers. And then I felt like this type of event was kind of like a club for professionals as opposed to like at school. And I really missed that because I always involve myself in those organizations. So I was attending a lot because I found it fun to discuss with people, and it actually has helped me greatly professionally, because I've even done some presentations, and then I'm also a stream owner now, and I have to prepare for each paper. Like, I actually have to like read through it in depth so I can ask the speakers, the authors of the papers themselves, like I guess relevant questions. And it actually gives me so much more confidence, like talking to new people in the field. And I mean, when I was interviewing for my new role as well, right? Like, if you have been able to talk about any project in such depth, like it really helps you, whether it's in like any professional environment or if you happen to be interviewing. I'm just saying that out for practical reasons. Like, that is like a very minor part. But
yeah,
intense.
definitely. I want to add on to the part of it helping us professionally. Definitely at my current role, I think one thing about what they liked about me was my involvement at AISC. So companies, they really love having somebody who's out there promoting their company in the community. And then also, yeah, we're learning all of this cutting edge research, and we're coming back to our own work with ideas about how we can implement this and what novel things we can do. So I think AISC, it's so beneficial overall.
Yeah, no, that's great. Yeah, I think it gives people a sense of what to expect, and we hope that it's great that people are here, and if they choose to step up and get involved more, all the better. Cam had a really interesting question around algorithms at use in Rex's context, and Susan was about to speak to that.
Yeah, I was just saying that I chose some stuff that's based in matrix factorization because it's able to handle like large amounts of data and using PySpark library, which is pretty good for that. But then actually there's I'm going from simple to kind of complex. And I guess for simple, another way possibly, like Omar mentioned, actually, it's kind of like a big like multi-label or multi-class, depending how you want to see it, problem for Rexus. So actually you could even use like XGBoost or something for it, to be honest. And then of course, like there's a lot of other ways. I mentioned you have to kind of extract information from, let's say, weblogs or kind of like item metadata, which you can do with multiple any type of methods like encoders or like other types of stuff in the ML field. But then of course, like I guess Omar, you can probably speak to the more kind of methods that maybe have more to do with like neural networks or what you did.
Sure, I can, but may I get the question again, because I wasn't here for the question itself.
Oh, sorry, Omar. We're just speaking about different algorithms at play.
Okay.
Yeah, my question, Omar. My question was just like, can you describe like a sliding scale of algorithms from like simple to complex, or like ineffectual to effective, or like maybe for some examples of different types of situations that could arise? Yeah, thanks.
Yeah, so basically there's the very basic normal content-based and collaborative filtering, right? So that's the basics of a recommender system. When you're talking about content-based, you're trying different similarity functions to see how far are you from using the same, like from liking the same information. But if you're talking a bit more about research and like competitions, I think everything has to be neural network right now. I don't think there's anything from this research or the competition perspective that haven't been won by a neural network. If you're talking about practicality, most of the very basic matrix factorization by itself can do the job for you. If you're talking about industry, right? So I know that with my previous job before RBC, they were very interested in deep learning, but then when I just did very basic matrix factorization, the online matrix, which is the evaluation of the commander engine online, it didn't have much of a difference. So matrix factorization 90% of the time can actually do the work without having too much computation power or without doing a lot of data cleaning and data transformation.
Great. I think one of the things that's coming out of this for me is the need to brush up on my algebra, since it's so important. I had a question. I hinted this a little bit earlier, but I want to talk a bit about the dark side of recommender systems, if indeed there is one. I don't know. Netflix recommended to me that I should watch the Social Dilemma documentary. It's a real downer, and it's basically about how a lot of AI is used to influence people's behavior, make them essentially to addict them to their devices such that information about them can be sold to advertisers. And it just got me thinking about ethics and that how recommender systems tie into that. So maybe I'll ask you, Serena, to start your thoughts on this.
Yeah, definitely. And I haven't watched that movie yet, but one really cool thing is that one of our speakers at one of our ACE events, Joe with the cool hair, I think his company is called Beacon or something like that. Yeah, he spoke at one of our events, and then he was in the Social Dilemma. So I thought that was so cool when I saw that. I was like, I know him kind of, but not really. Yeah, so I think ethics, and that's a very important topic in all of machine learning and recommender systems too, of course. So yeah, there are definitely ways that companies can be unethical with their recommender systems. So for example, companies might want to recommend their products over the products of smaller manufacturers. So let's say Amazon, for example. I think many of you might have noticed that a lot of the products that are showing up at the top of your page when you search for something are Amazon basics, and it's becoming increasingly difficult to find a legit product that is not an Amazon product. So that, yeah, it makes it very hard for small businesses to compete. And I would say that that is, in a sense, unethical, but also in another sense, it's Amazon's platform. Of course, Amazon can promote their own products first. But yeah, so in a similar vein, talking about product recommendation. So not saying that we did this, but I'll use an example from my previous job just to illustrate the idea. So like I said, I worked on building a grocery product recommendation system. And let's say that, for example, there was a push towards, let's just say, plant-based products being purchased in a particular, not just a particular grocery store, but let's say that it became clear to everybody that millennials wanted to purchase plant-based products. And maybe the meat industry doesn't like this. So the meat industry could then lobby the either the grocery stores or the, let's say, the company that's building the recommender system itself. And they could say, hey, can you actually re-rank meat products over plant-based products so that we can make more money? So that's not doing what the consumer really wants. That's just pushing the agenda of the organizations that want to make more money. So I would say that that is unethical as well. And really just whoever has money, they control what we are going to interact with and what our experience is going to be. And then another issue that Sebastian asked about in our breakout room, and this is actually this question overall is very similar to what he asked, and I started talking about YouTube. So YouTube and its video recommender system, I think there's an ethical problem there. So there's a great talk that was led by Omar. When was it? May or something, 2019, maybe something like that. So you can find that on our website if you want, and I facilitated it and it was a great time. And in this talk, Omar went through all of the steps involved in building YouTube's recommender system. So what we had learned through reading their paper was that YouTube previously prioritized videos, I think, with long, or videos that people would watch, and people would watch for a longer amount of time. And what we then learned has actually happened is that YouTube has now changed their algorithm, so they prioritize videos that are just clickbait, so that people will click on them and then they might not necessarily watch them. And what I think this means is that, yes, you can put a lot of ads in a longer video, but you can put an ad at the very beginning of a clickbait video. Someone will watch the ad, maybe they'll watch 10 seconds of the video and they just will be disinterested, and then they'll move on to the next one. And there's more of an opportunity because there's going to be an ad at the beginning of every video. YouTube can make more money that way. So they're really just after money. They're not after the ethics, or sorry, they're not after creating a better experience for the user, which I do view as unethical. And then as an anecdote of what I've experienced with YouTube's recommender system. So there's one time I was watching some vegan cooking videos on YouTube, and for some reason I left my YouTube browser open. And then hours later, I came back to it. And then I saw the sequence of videos that I had watched because I had autoplay on. And suddenly I made it all the way to flat earth videos. So somehow I went from like plant-based cooking to flat earth. So it really just shows how this sort of recommender system, it just sells disinformation, and it actually is a bit dangerous. So they're really not taking an ethical stance here. They just want money. And yeah, I think there's definitely a problem with that.
It's not flat. It's not flat, eh? Okay.
Yeah, I'm sorry to break it to you.
Okay.
But just to add to this, actually, even some of the features that, for the clickbait talk that YouTube started having, Susan covered that talk before. And honestly, what disturbed me is not only that, but the fact that even some of the features that are being inputted to the model itself, in my opinion, was not too ethical. Like they would engineer some features that would lead to, like, I remember Susan had that joke in her talk where saying, like, just because they realized that she is a female, they started showing Taylor Swift and other kind of videos, but not for the male, right? So it's a lot of, in my opinion, it's not very ethical also in the features that are being fed to the model, not just the optimization.
Yeah. Second. That.
Okay, great. I think the question that comes up then is, as people working in the field, what can you do? Are there things that people working on RecSys should be aware of, or specific tactics they can engage in to try and counteract this sort of thing? Or are you powerless against the corporate overlords?
is that for
I can take it to start
Sure.
with, but
Thanks.
also I'll start off the conversation. But just my main point would be that this is a question that doesn't just apply to recommender systems, it applies to machine learning overall. And I don't think the solution, again, is specific to recommender systems. And this is something that I'm very interested in with the work that I'm doing with aggregate intellect and diversity and inclusion. But the problem is I don't know what the solution is really. So there's one way that you can look at it, and that is we need to make sure that people who are developing machine learning models come from a diverse background, because if you have a team that all looks the same, then, or let's say it's all females who live in Toronto, let's just say, because that's using me as an example, we're going to end up building products that are going to be helpful for people in that particular demographic, because that's what we have in mind. And I mean, there's nothing wrong with that, but that's just what's going to happen. So on the one hand, we need to have a diverse group of people who are interested in machine learning, educated about it, and building these products. And on the other hand, there are certain checks that can be done to make sure that whatever we're building is not biased. But without having a diverse group of people who are building these products, it's going to be difficult to surface these questions that you need to ask. So I think it's important for developers to really think critically about not just who are these applications going to help, but also who are these applications going to harm. Anyway, so that's my attempt at starting off the conversation. But I'm really curious to hear what Susan and Omar think about this too.
Me too.
And anybody else too.
Yeah, I guess can you just like repeat the kind of core of the question again?
Essentially, we're in this situation where ethics come into play. As someone working in Rexis, what can you do about that?
Right. Yeah, I guess I guess it's similar to what Serena said, but then there was one thing that someone had brought up recently, which is, I would say, is more a general ML thing. Like if there were some sort of data lineage or privacy tools where if someone opts out of doing something, then the data wouldn't enter the training set. But I guess this is like hypothetical. Like I think in terms of, let's say, cost, like I think we're I think to implement that, there's still like some ways till that in general ML, not just Rexis. Yeah, but that was like something interesting I had come across lately in that topic.
Okay, thanks,
I
Susan.
100% agree with Susan. It's not just Zexis for multiple reasons. Like as I mentioned, Zexis is not a class of machine learning. It's just a task, right? So just personalization task. And what you feed to the model is what is gonna be the reason why either it's biased or it's fair. If you feed it data that has a bit of unethical features in it, then definitely the model is going to use that data, and the output is going to be unethical. If you are going to feed it, like even if it comes on the fact that the accuracy is going to be less, but if you make sure that it's only ethical features and features that you are 100% sure it's not going to be biased towards anything, then the model is going to be fair. That's one thing. The second thing, in my opinion, it wouldn't be the data scientist as much as the corporate life, right? So if I don't know, the CTO of a big company says we are not going to use these features, then the data scientist wouldn't be able to use it even if they wanted to. But then if they were given those features and they have like the main responsibility for the data scientist is to come with a super accurate model, they have to use whatever features is there. So I think it's much bigger thing than just data scientists. I feel it has to come from the bigger teams, from the senior managers.
No, that makes sense. Maybe shifting gears a little bit, I thought I would ask you guys about what's new in Rexis. I mean, this field has been burgeoning for a while. Given that you guys work in it, is there anything new, different, cutting edge that should be on people's radar, people who are in this room? Serena, to start, maybe?
Yes, very happy to start. So I would say that I might end up speaking for Omar just because, well, it'll become clear soon. So a lot of what I consider to be cutting edge and exciting in recommender systems is taking work from other domains, in particular natural language processing. And that stems from, well, yes, it's interesting to use these methods in recommender systems, but also personally, my background has always been very interdisciplinary. So I really like the idea of taking solutions from seemingly disparate domains and applying them to new domains. So in particular, Omar and I are currently working on some research using BERT, which is a formerly very cutting edge, but has since been replaced with new cutting edge models. It's an NLP model, and we've been using it for session-based recommendation and working on a paper for it. And session-based recommendation is just recommending products to people when they're shopping online in an online session. And using natural language processing methods, it works very well because oftentimes recommendation, you can think of it as a sequential problem. So given somebody has clicked on a few items, what are they going to click on next? And in NLP, oftentimes you're trying to predict the next word or next sentence someone might say given something they've said before. So I think it's really exciting to use these NLP methods and just, yeah, rather than thinking of recommender systems as one particular subdomain with a bunch of very specific models you can use, I think it's exciting to think about recommendation as a sequential problem. Then it sort of opens up all these other opportunities for new models that you can apply, again, particularly in NLP.
Great.
Anyway, so then I want to leave space for Omar to say more about this because I could just continue talking about it, but then I would be speaking for you.
No, you covered it pretty well. So in my opinion, for the past year, session-based accommodation have been the new of recommender system. So up until last year, recommender systems have been using historic information. So you bought something, I don't know, 20 years ago, which still has the same effect as something that you just bought 5 days ago. That's the old version of recommender system, but now it's more about you clicked in product 1, product 2, and then product 3, and you ended up in purchasing product 4. So that sequence has some information, and that's, I think, where the recommender system is going right now. So NLP is being explored a lot actually right now because of the sequential behavior. But what I've noticed in Nexus 2020, actually, almost 40% of the papers that are starting to deal with session-based is using reinforcement learning now. So that is something that I will be very interested in to start exploring. And I see Susan is happy about that.
Susan.
Yeah, I was definitely, sorry, I was just going to add to that because I was going to say I'm really excited for a lot of implementations in Rexis and reinforcement learning. Actually, Omar and I have kind of like teamed up like on multiple AISC talks about this, like at least 3, including the one that I did, maybe 4, I forget, but like it's like very, very exciting, and it enables the I guess Rexis to include like the benefits of reinforcement learning, which is being able to learn through trial and error, and then how the interactions are captured. So I think that's like I'm really excited about that.
Yeah, that's great. No, that's palpable excitement. And I think one of the messages is people should check the archives and hear all those other talks that you guys have worked on. This is the final lightning round. I have just one quick question for my panelists that I had asked them to prepare for. Essentially, many things have been discussed tonight, but is there one more thing, one more resource, one more tool, one more interesting fact that each of you would like to share with the group, starting with Susan?
Sure. Yeah. So I actually had thought about this, and I think just for general learning purposes, like sometimes I like to go on different companies' engineering blogs, like let's say Google's engineering blog, or I mean for reaching out for papers, I kind of creep their blogs anyway. But I think it's a good resource to be learning things, and I learned a lot when I was making Rexis stuff or reinforcement learning by going to their blogs. And even like, let's say like other companies like Zillow's engineering blog had like some really great posts on Rexis. But yeah, just like look up company of interest engineering blog and then go there. Basically.
That's great, Susan. Serena.
Yeah, I'm going to piggyback off of Susan's answer and call out one particular engineering blog, Stitch Fix. They have a really great blog and they talk about production, I think. And they also talk about A/B testing, which is something that's very interesting, which we didn't end up touching on. So I encourage you to go take a look at Stitch Fix. And also just, I mean, it sounds lame, but Google is a great resource. So I mentioned A/B testing. You should try taking a look and Googling A/B testing for recommender systems, for example, and see what comes up.
Yeah, for sure. I know that that's actually been raised as an ethical question, given that in AB, by definition, two people are given different sets of information. I actually subscribe to a couple of different newsletters on behalf of myself and another person. And I can always see when the headlines are different or when the images are different. It's a funny thing. Omar.
Yeah, so I'm a bit more, I really like books, so I really like digging a lot deep into books. And there's this recommender system book that I've been in love with. I couldn't finish it yet. But my advice, and that's what I've been telling the breakout rooms, is try to get technical, but also show off your information by writing blog posts, doing jobs, doing like dealing with data sets, doing modeling in a different aspect from what everyone else is doing, and try to put it in a blog post. That's how you get noticed, and eventually that's how you get the job that you want.
Yeah, no, that's great advice, Omar. Thank you. So I think it's time to wrap up here. I am so excited about the fascinating conversations that have been going on. So grateful to my panelists tonight and everyone who took the time to attend. So I'll just remind you as we close out, AI.science is the place to go to sign up for a free account so that you can be kept abreast of stuff that ACE is doing at all times. You can also add Aggregate Intellect on LinkedIn, and you can go to our YouTube channel as well, ML Papers Explained, if you want to be totally in the loop, which is what we want. I hope that you guys will come back to this event too. It happens every 4 weeks, and really glad that you're here. Thanks so much, and have a great night, everyone.